Hello friends, ਅਸੀਂ ਅੱਜ ਸ਼ੁਰੂ ਕਰ ਰਹੇ ਹਾਂ Coulomb's law, which is the first lecture in the series of electrostatics. ਅਸੀਂ basics ਤੋਂ ਸ਼ੁਰੂ ਕਰਾਂਗੇ ਤੇ slowly degree of difficulty numericals ਦੇ concepts से increase ਕਰਦੇ ਜਾਵਾਂਗੇ. I hope ਕਿ ਅਗਰ ਤੁਸੀਂ ਸਾਡੇ lecture ਮੇਰੇ ਨਾਲ follow ਕਰੋਗੇ ਫਿਰ ਤੁਸੀਂ ਇਸ chapter ਨੂੰ JEE mains ਦੇ ਜਾਂ advanced ਦੇ level ਤੱਕ prepare ਕਰ ਸਕਦੇ ਹੋ. तो शुरू करते हैं Coulomb's law ਤੋਂ. Coulomb's law basic law है, दो charges ਦੇ ਵਿੱਚ force ਦੱਸਣ ਵਾਲਾ. अगर two charges are there, let's say Q1 and Q2 separated by distance r, then Coulomb's law says that force is proportional to product of the charges and inversely proportional to square of the distance between the two charges. So standard inverse square law, nature like favorite law, उन Coulomb's law भी follow करता है. Sign of proportionality हटाने के लिए सानू कोई constant of proportionality लगाना चाहिए. तो F is equal to K Q1 Q2 by r square. This is the basic form of Coulomb's law. Now this constant of proportionality K depends upon two factors. First factor is that what system of unit you are working in. अगर तुसी CGS system च काम कर रहे हो, CGS system च, तो फिर K की value 1 है. अगर तुसी SI system च काम कर रहे हो, तो K की value है 1 by 4 pi epsilon naught. This epsilon naught is called absolute permittivity of free space. ਅਸੀਂ assume कर देते हैं कि ये दो charges खाली vacuum च पड़े हुए हैं. तो absolute permittivity of free space में epsilon naught की value है 8.854 into 10 raised to the power minus 12 Newton meter square, Coulomb square per Newton meter square. As सारी value epsilon naught की इधर put करके you can find out the value of K, which will roughly come out to be 10 raised to 9 to 10 raised to the power 9 Newton meter square per Coulomb square. So it is better, it seems better that we in CGS system K is simply 1 and SI system K is equal to 9 to 10 raised to the power 9 Newton meter square per Coulomb square. We'll be using SI system normally. However, if you are using CGS system, then Q1 and Q2 should be taken in stat coulombs. That is the CGS unit of charge. R should be taken in centimeters and obviously F should be taken in dynes. Whereas if you are working in SI system, then Q1 and Q2 will be taken in units of coulombs and this distance r will be taken in meters and F will be taken in newtons. So the first question arises, how many stat coulombs are there in one coulomb? We'll solve that later on, but first we'll see on what is the second factor on which the value of K depends. The second factor on which the value of K depends is the medium separating the two charges. It is the medium separating the two charges. The force between two charges is maximum when they are in vacuum. When you put them into some medium, the force gets decreased by some factor. The factor by which the force gets decreased as you put two charges into a medium, keeping them same distance apart obviously, then that thing is called the relative permittivity of that medium, or simply called dielectric constant. So what we are saying, in vacuum, let's say the force between these two charges was F vac, that is equal to 1 by 4 pi epsilon naught Q1 Q2 by r square. Now as you put these two charges into the medium, let's say water, then what happens? The force changes by a factor epsilon naught K times Q1 Q2 by r square. Actually epsilon naught times K is also called absolute permittivity of the medium, and K is dielectric constant, or it may also be termed as K, or which is normally can be called as epsilon r, is epsilon m divided by epsilon naught. It is called a relative permittivity of that medium. For example, for water, its value is approximately 80. So that means if the force between two charges is F, and you put them into water, keeping this charges same and the distance between them again same, then the force will decrease by a factor of 80. K is a dimensionless number, and its value will be different for different mediums. This brings us to a very interesting question, and I hope you will write the answers in the comments. Why do electrolytes split up into ions when dissolved in water? I hope you already know the answer. Why the electrolytes, for example, sodium chloride, when you put it into water, dissolved into water, what happens is sodium ion and chloride ion get separated. Can you correlate this topic to this? I hope you can. Next is, so till now what we have done, primarily what we know is Coulomb's law in SI system is written as 1 by 4 pi epsilon naught K, Q1, Q2 by R square. If the charges are in vacuum, K will be 1. If it is in water, it is approximately 80. But what? And different materials, oil, mica, they have got different values ranging from 4, 6, 12 and so on. But all the metals have got K infinity. K approaches infinity for all the metallic materials. That means dielectric constant of iron, say iron, copper, zinc, or any other metal, you name it, any other conducting metal, all metals are conducting obviously, the K approaches infinity. So that means if you keep a metal between two charges, I am assuming this medium to be extending right there, filling it completely. These two charges. The charges are just at the just beyond the surface of the metal. Now, what will be the force between these two charges? Let's see. F will be 1 by 4 pi epsilon naught, and here K is infinity. So, what would be force? As K is tending to infinity, force is tending to 0. As K is tending to infinity, the force is tending to 0. Now there are two more questions which I would like you to answer. The number one, I want to save something from from the effect of any other charge. That's what we call as electrostatic shielding. When we want to save something from the effect of other charges around it, that's called electrostatic shielding. If, let's say, this is a sensitive instrument and I want to save it from any other from the effect of an electric field of any other charge, where should I put it into? Should I put it into a concrete box? Should I put it into should I put it into water? Should I put it into a wooden box? Or should I put it into a metal cavity? I hope you know the answer if you have understood this topic. And one more question. Have you ever wondered why all metals are opaque? Have you ever wondered why all metals are opaque? There is not even a single metal which is transparent. Do transparency has got something to do with dielectric constant? You can think of it as that if a material has got free electrons, that means it's conducting in nature like metals, its K will be infinity, and there will be no electric field existing in that material. And what will happen? This will lead to a situation where electromagnetic waves, which is normal light, like this, the normal light would not be able to penetrate into it because the electric field inside it will attenuate to 0 immediately. That means no material with free electrons, having sufficient number of free electrons, can be transparent because the light will not be able to pass through it, as its electric field cannot be sustained inside it. However, this is if a material, you can do it in the other way around. If a material is transparent, say glass, So what does that mean? That means that it doesn't have any free electrons, or very less number of free electrons. That means that this condition of having no free electron, very less number of electron for transparency is the necessary condition. It's not the sufficient condition anyways. This was the first part. In the second part, we'll see we'll calculate how many stacked coulombs are there in one coulomb. Thank you.